everyone, and welcome to our next lesson, 1.1, Day 2. Today we are going to talk about the properties of segments and finding their measure. So something that isn't unique to this class is the idea of a segment on a number line. So we know that the distance between 2 points, for instance, C and D, is 3. So we could say the length of segment CD is 3 units long, and we find that by just counting. So we could see, for instance, with number 1A, segment AC, to move from our point at A at -3 to C over here, we would go 1, 2, 3, 4 units total to get from A to C. So we would have a length of 4. Try BD and AD on your own. What you may notice is that B to D also happened to be 4 units, and A to D was a total of 8 units. What this brings us to is the idea of our ruler postulate, which again is going into the idea of where a coordinate is at. For instance, on this one, X is at 3, Y is at 7. So those are the coordinates that they are located at, as opposed to the length of the whole segment, the idea of distance between 3 and 7, which is 4 units. Now notice the use of the absolute value bars on this. Distance is always a positive number. Even if you move backwards 2 feet, you say that you move 2 feet, not -2 feet. So whether you do 7 minus 3 and get 4, or you do 3 minus 7 and get -4, you're taking the absolute value of it so that your distance is always a positive number. Same thing with measurements in general. When we measure something like this thumbtack, it's approximately 1.7 centimeters. Again, that is a length. Or we have this pencil that is about 2.25 inches, or maybe you called that 2.25 inches. But again, that length on those. Now, the idea of length is a little bit different than the segment. When we see AB with a segment bar on the top, that's indicating the segment itself, as to where if we want the length of that segment, we would put AB without the segment bar on the top. So that's asking you for a number, versus when we talked about AB with the segment bar on the top, that's the segment, the whole thing itself, not the length. Now, a postulate is a statement that we assume to be true. Like this idea of distance and counting, that's a postulate. We know that we count these, we assume that to be true. So again, if we look at these examples, J to K moving from 5 to 12, that's a total of 7 units. K to M going from 12 to 27 is a total movement of 15 units. That again is the idea of our postulate here, the ruler postulate, to just be able to count. Now, what happens if we don't want to go an entire distance? For instance, on our number line, we have 1 point at A, and that's located at -5 on our number line. And then we go all the way over here to point B, which is located at the number 7. And we want to put a new point somewhere on this line that's called C, but it's only 3/4 of our original distance. Well, first and foremost, our original distance to go from -5 all the way to 12 was a total of 12 units. And we could do 7 minus -5 and get 12, or -5 minus 7, take the absolute value. We know this is a total of 12 units originally. But we only want to go 3/4 of that distance. So to go 3/4 of the distance, what we're going to do is we're going to take our original distance of 12 and we're going to multiply it by that 3/4. Now, reminder to type a fraction in your calculator, you're just going to take 12 and you can multiply it by that fractional value. So we would move, now for our new point C, we're only going to move 9 units, right? So instead of moving all the way from A to B, 12 units, we're going to only move 9 units to get to our new point C. So if we add 9 to -5, 3/4 of the way, our new point C is located at 4 on the number line. Now, our ruler postulate also adds into the idea of a segment addition postulate, because what we know from here is that if we have a small segment plus another small segment, it will equal that total segment. So for instance, if this first segment is 3, second segment is 4, the total distance from A to C then would have been 7. What I like to say is that I like to call this small segment plus small segment is going to equal a bigger segment. Now, a lot of this, it takes an extra few seconds, but it's important that you draw yourself a picture. So notice it says on our segment, find the length of segment JL if K is somewhere between J and L, and the lengths of these are 13 and 22. So again, let's draw the picture. K is somewhere between our two segments, J and L. J to K is 13. K to L is 22. We want this total distance, which is going to be small plus small, 13 plus 22, for a total of 35. Let's try another one. This time we have BC, and we are looking for we're looking for the length of BC if B is between A and C. So again, we got to start with a picture. B is between A and C, so it's going somewhere in between our two pieces, our 2 points on the number line. This time they're telling us A to C, this whole big thing, is 12. A to B is 7, and we want to find the other piece, B to C. Now, this time we're in a slightly different situation because we have the big segment, we need a smaller segment. So small plus small equals the big. So instead of adding, because we already have the biggest segment, we're going to subtract, like we solve an equation, to get that missing piece, that BC is a total of 5 units long. So sometimes we're going to do big minus small to get the other small. That's why a picture is so important. Now, we can also deal with the idea of some algebra and solving in order to find our distances. So notice these are collinear points telling us they are all on the same number line, just like we've been drawing. And they are telling us that we have a segment FG, which is 3x minus 6. We also have a segment GH that is 2x plus 2. And if you notice from the given information, they're also telling us that G to H equals 16. Now, this is an important piece of information because we're going to use that information to help us solve for x, because 2x plus 2 has to equal 16. Now, to find x, to solve for the value of x, we're going to solve this equation. We're going to get that x by itself. So subtract 2 from both sides, and then divide by 2 to get x by itself. We first find that x is going to equal 7. Now, the second step then is they want us to find the length of F to H, this whole segment here, right? Now, when we plug this back in, we know part of H is going to be G to H, which is 16. We're missing, however, F to G to find what that total distance is. So the first thing we're going to do is we're going to plug back in to FG. And so we have 3x minus 1. We're going to take this 7 and plug it in for x, and then subtract it away. 21 minus 1 is a total of 20. Well, now that we know that G to H is F to G is 20, we can find our total segment F to H by adding those two values together. 20 plus 16 for a total of 36 to find our final answer. All right, the next one, they have labeled the pieces for us that j to k is 3n, k to l is 5n minus 7. They also are telling us that j to l, this whole thing, is 25. So again, we want the idea of small segment plus small segment equaling big segment. What do you think that setup's going to look like? Hopefully, you're seeing that our two small segments, 3n and then 5n minus 7, need to equal 25. So an important step before we can start moving things across, we're going to condense 3n plus 5n. So we have a total of 8n. And then we're going to move across our equal sign. That negative 7 will be added so that we end up with 8n equals 32. And then 32 divided by 8, we get our n to equal 4. Now again, there comes a point where we are going to then plug this back in for our missing pieces. So first piece they want us to find is j to k, so 3n. So j to k, we're going to take 3, and we're going to plug in that newly found n value of 4. That piece is 12. And then k to l was this piece right here. We're going to take 5 and multiply it by n. And this time subtract away 7. So 20 minus 7 is 13. So we answered all three pieces. What is n? What is j to k? And what is k to l? All right, now down here at the bottom, we're going to start by drawing because they want us to find two things. They want us to find x and df if E is between D and F, point E, and then we're going to label D to E is 2x plus 10, E to F is 3x plus 15, and then D to F is 20x plus 10. Take a moment on your own to set up and solve an equation. You're going to start by finding x. Now that you found x, you are also going to want to plug it back in because we have 2x plus 10 plus 3x plus 15 equals 20x plus 10. When we condense things down and simplify, we end up with 5x plus 25 equals 20x plus 10. Move across that equal sign, the 5x. Move across that equal sign, the 10. And finally, we get x to equal 1. Also plug back into df. This time you should have gotten 20 times 1, but plus 10 to be 30. All right, we have one final example today. Again, make sure you start by drawing your setup. This time B is between A and C. And then solve for x. This time you do not have to plug back in. Thanks everyone for watching. We'll work more with these in class.